Namaste and greetings. I, Priyanka Negi, researcher at IMPRI, Impact and Policy Research Institute, Prabhav एवं नीति अनुसंधान संस्थान नई दिल्ली, extend my warmest welcome to you all to IMPRI Web Policy Learning. Today marks the inaugural day of Understanding the Nuances of Climate Change in the Indian Subcontinent, Cohort 2.0, an online international monsoon school program, a 2-month immersive online introductory certificate training course. The program is organized by IMPRI, Center for Environment, Climate Change and Sustainable Development. To kick things off, let's begin with a concise overview of the program. Climate change is a complex and far-reaching phenomena with profound implications worldwide. The Indian subcontinent is particularly vulnerable due to its large population, widespread poverty, and reliance on agriculture and natural resources. This region's diverse geography, including deserts, fertile plains, mountain ranges, and a long coastline, contributes to its susceptibility to extreme weather events. Human activities have intensified occurrences of heat waves, droughts, floods, agricultural losses, and cyclones. As climate change worsens these severe weather events, the Indian subcontinent faces significant social, economic, environmental challenges. Addressing these interconnected impacts requires a coordinated and sustained effort from various stakeholders, including individuals, organizations, communities, governments, civil society, and the private sector. In response to these pressing challenges, the IMPRI Center for Environment, Climate Change, and Sustainable Development presents the second cohort of this transformative course. This program aims to spark discussions on climate change in the Indian subcontinent and South Asia, fostering effective awareness, adaptation, and mitigation strategies. Participants will explore essential approaches and innovative solutions to build a more resilient future. Join us in this crucial initiative to tackle climate change in the Indian subcontinent, equipping ourselves with the knowledge and tools needed for a sustainable and resilient future. This program has an excellent panel of experts who will be sharing their expertise for the duration of this program. The distinguished expert panel includes Mr. Soumya Dutta ji, Mr. Arjuna Seneviratne ji, Dr. Bamadev Sigdel ji, Professor Rekha Niyanti ji, Mr. Himanshu Shekhar ji, Professor Anil K. Gupta ji, Ms. Bhargavi S. Rao ji, Dr. Brajesh Kumar Dev ji, Mr. K.J. Joy ji, Professor Vibhuti Patel ji, Dr. Khundakar Gulam Muazzam ji, Professor Sas Biswas ji, Ms. Bhavreen Kandhari ji, and Advocate Dr. Albertina Almeida ji. Our chair for the program is Ms. Bhargavi S. Rao ji, independent researcher and educator, environment activist, Bengaluru, and visiting senior fellow at IMPRI. The conveners for the program are Mr. Tikendra Singh Pawar ji, Dr. Simi Mehta ji, and Dr. Arjun Kumar ji. Proceeding further, I heartily invite you all to this course, Understanding the Nuances of Climate Change in the Indian Subcontinent, Cohort 2.0. In this program, we come together with a shared goal to deepen our understanding of climate change and collaborate towards building a better, more sustainable, and resilient future. We sincerely appreciate your valuable time, energy, and contributions towards understanding and engaging with this significant issue. We have also shared the course outline and reading resources for your kind reference and perusal. Before we start today's session, I would like to announce the housekeeping announcements. It is imperative that you join the meeting on time. There will be a Q&A session after each presentation. Share your questions in the Q&A box and not in the chat box. The questions must not be posted as an anonymous attendee. Ensure that your questions are precise. Refrain from making general comments in the questions to save time. Now, without any further ado, to begin today's session, I would like to invite our chair, Ms. Bhargavi S. Rao ji, for her opening remarks. We welcome you, ma'am, and the floor is all yours.
Thank you. Thank you, Priyanka. I'm assuming everyone can hear me now. Yeah? Okay. So, good evening, everyone, and it gives me great pleasure to chair another series of the online programs offered by IMPRI. I thank everyone at IMPRI for this opportunity. Today, I want to bring to light the intricate relationship between climate change and the Indian subcontinent, a region where the impacts of climate change are felt so acutely, often with devastating consequences, and this is unfolding on our TV screens and social media. It has been very disturbing, and it just has opened up a whole lot of questions for discussions and debates. The rise in landslides, floods, and other extreme events are being witnessed, and rescue efforts are on even as we speak. The Indian subcontinent, with its diverse topography ranging from the towering Himalayas to the vast plains of the Ganga, is very uniquely vulnerable to climate change, and the threats have only increased with deforestation and the irrational developmental practices. And this ignoring a variety of studies and reports produced by various committees and academicians and civil society. The monsoon, which is the lifeblood of the region, is becoming increasingly unpredictable. Traditionally, the monsoon rains have provided water necessary for agriculture, supporting the livelihoods of millions. And as a child, I remember walking back from school in the rains was never so, filled with horror. Today, the minute it rains, we're all ensuring our family members are back home or in their safe places. So, such erratic rainfall patterns and shifting seasons are now threatening food security, exacerbating poverty, and triggering mass migrations. Rising temperatures also pose a very serious threat. The frequency and intensity of heat waves are increasing, leading to severe health crises, particularly among the poor who lack access to adequate cooling. The agriculture sector, again, which employs a little nearly half of the population, is again under immense stress as crops fail due to both excessive heat and untimely rains and a variety of other factors. Further, the melting of the Himalayan glaciers, often referred to as the water towers of South Asia, is another alarming concern. These glaciers feed major rivers like the Ganga, Brahmaputra, the Indus, and others, which are crucial for drinking water, irrigation, and hydropower. As these glaciers recede, the region faces the dual threats of water scarcity, flooding, which could also lead to conflicts over water resources. But climate change doesn't just affect the environment, it has a very deep social and economic and cultural implications as well. The most vulnerable populations, those who are least responsible for climate change, are the ones who are often suffering and who bear the brunt of it all. And very often they are also pushed to a point from where things are irreversible. They are pushed into deep intergenerational poverty. And perhaps even pushed to a point where the generations ahead are unable to catch up with basic education, healthcare, housing, and some of the basic needs. So this includes small farmers, indigenous communities, and the urban poor who lack the resources to adapt to these changes. The need for equitable climate policies and strong governance has never been more critical. While the challenges are formidable, the Indian subcontinent also has a rich tradition of resilience and adaptation. And many of these are from the traditional knowledge of the indigenous communities, from innovative water conservation techniques to community-driven forest managements in many parts of the very Western Ghats where we are seeing the landslides today. There are stories and lessons in good practices that need to be perhaps learned, and if not replicated, it needs to be adapted to the local context. There is clearly a need to identify the highly ecological sensitive regions and reimagine the boundaries of human activities and settlements. And in conclusion, Understanding the nuances of climate change in the Indian subcontinent requires us to recognize the complex interplay of environmental, social, and economic factors. It is a challenge that demands not just global action but local solutions that are rooted in the realities of the people who live here. And by working together through such programs and understanding these very nuances through the diverse lectures that have been curated together, I am sure we can build a future that is not only resilient to climate change but also equitable and sustainable for all. So without wasting much time, over to our experts, and thank you so much.
Thank you so much, ma'am. That is a very insightful introduction to the program. Moving forward, I am delighted to invite Mr. Soumya Dutta ji, co-convener of the South Asian People's Action on Climate Crisis, SAPACC, New Delhi, and visiting senior fellow at IMPRI. Sir will guide us on understanding the impact of climate change in South Asia. We welcome you, sir, and the floor is all yours.
Thank you, IMPRI team. Thank you, Bhargavi, and good afternoon to everybody who has joined. When we are talking about climate change in the Indian subcontinent is a term that is not very often used in terms of ecology. So in ecological terms or environmental terms, either you go by the political boundary of India or you go by South Asia, because South Asia is basically connected in terms of ecological aspects by the three ecological aspects of the three seas: Bay of Bengal, Indian Ocean, and the Arabian Seas, the Himalayas, and the southwest monsoon or the summer monsoon. And of course, the connections of culture and families and all, everything, languages, that persists. But these three major ecological connectivities actually connect South Asia, and we have to consider South Asia as one unit when we talk about any major ecological issue, including the threat of climate crisis. So today, since this is the beginning, I will briefly talk about some major issues about the climate change, what is happening and what kind of issues we must be aware of and understand deeply in the Indian subcontinent or in South Asia, or if you like, India and its neighboring countries in South Asia. Second, I'll also briefly mention the basically four kinds of geographies. One out of these four is not exactly geographically defined geography, but is a human defined geography. So I'll talk about the four different kind of geographies that are now have emerged and are emerging as the most vulnerable, and where most of the actions needed to be now focused on. I'll also briefly talk about the different, not all, because this is a very large area, not all sectors, some major sectors which both impact and are being impacted by climate change, which influences climate change and also are being impacted, influenced by what is happening as a result of the climate change. And lastly, I'll talk about a few measures where people on their own can do. I'll not go into details, we'll not have the time for that. And what are the governance mechanisms in India? Because when we talk about governance mechanism, that comes with the political boundaries and political identities. So what are the governance mechanism, different governance mechanisms for climate related issues in India? So let me start by focusing on some major, just the highlights, because again, such an issue to be covered in detail will need maybe 2 months, 3 months daily course, everyday course. So that will be quite detailed. So let me just focus on some major issues that are so important, and if we need to understand and act, more than understand, need to understand and more have to act on this, we need to understand what is happening in the Indian area and in the South Asia. Obviously, one of the issues or one of the major impacts that, because the heading of the webinar, it says both, because now it says also the impact, understanding the impacts of climate change, but impacts also are including what kind of actions you do, that also determines some way the impacts that you face. So one of the major things that everybody understands, because the climate change that we are talking about is coming basically from the rise in temperature along with some other measures. So the most important driving measure is the rise in temperature. So one of the major parameters or issues that we need to understand and know is that what kind of temperature rise has happened and is happening, and what are the trend over the Indian landmass. And Indian landmass will include basically the coastal waters, but not the seas that surround us, not our economic zone, but our coastal waters. So if you have seen the results over the, it's one of the anomalies in climate change science that even though last year, as all of you know, 2023 was the globally the hottest year ever recorded. And recorded means the recording of global temperatures from large number of weather stations started around 1860. So in the last 160 years, out of all the years that have been recorded, 2023 was by far the warmest year ever recorded. And some of the earlier other proxy records, which goes back to around 8,000 years plus, shows 2023 might have been the warmest year in the last 8,000 years, almost in our entire Holocene period. And to remind us that the Holocene period of the last 10,700 to 11,000 years was the period when human beings started, or not exactly invented, but started agriculture in large scale, started building cities and civilization as we understand, and became what we are today, from basically hunter-gatherer societies. All that happened in the 2.5 lakh year Homo sapien history, all that happened in the last 10,000 years, roughly. So one of the reasons for that is that in the Holocene, entire Holocene period, the climate was extremely stable. And this is, again, one more surprising thing. Over a 10,000 year period, the average temperature, 1 year, 2 year, it has changed more than that. But over a 5-year period, average temperatures have never gone beyond a 1 degree Celsius boundary, this way or that way. But over the last 100 years, we have crossed almost 1.28, and now last year was 1.48 degrees Celsius above pre-industrial average temperature. Pre-industrial means the average temperature from 1850 to 1900. So that's the kind of, every month has a pre-industrial average temperature. Some of the months we had average temperatures which are 1.73 degrees Celsius above the pre-industrial for the same month, pre-industrial average for the same month. And 2024 is at least till June, because July we don't have the data, at least till June is showing the same trend. It is going above 2023. So unless things change drastically in the next 5 months, we might end up, 2024 might end up being the warmest warmest year ever recorded, and maybe also in the last 10,000 years. So that's the kind of trend about rising temperatures that we are facing. And this is a very serious issue because rising temperatures have multiple consequences. I'll come to some of this. But beyond land temperature, and the temperature that I told about, 1.48 degrees Celsius above pre-industrial, that's only the global average. The northern hemisphere land surface temperature actually has gone more than 1.6 degrees above the pre-industrial average. But the anomaly that I was talking about, the temperature rise over the last century plus, almost 118 years, 1901 to 2018, over the Indian landmass only is much less. It is around 0.71 degrees Celsius. There are reasons for that. Not everything is fully understood, but the Indian landmass temperature rise over the Indian landmass is lower than the northern hemisphere landmass temperature rise, and even lower than the global average temperature rise, including the seas. The second most important impact that we are having, and which these are macro impacts. So first, let me talk about some of the macro impacts, and I will come into different sectors. The second most important macro impacts that we must understand, that the sea surface temperatures around India, and this is not just across India, globally the sea surface temperatures have gone unusually high. They have risen much faster than the average temperatures in the last 2 years. 22 and 23 and 24 is also showing the same trend. But around the Indian landmass, the West Arabian Sea, Bay of Bengal in the east, and partly in the northern part of Indian Ocean, the sea surface temperature, the average temperature of the first 50 meters of the sea, first 50-meter depth, has gone up much faster. And this has happened in a more drastic manner over the Arabian Sea than over the Bay of Bengal. There are, again, multiple reasons for that. The Arabian Sea being much more enclosed body of water, the African continent on that other side. So all these are factors, but there might be other factors which climate scientists will be coming out with. But the fact is, the sea surface temperature over the Arabian Sea has gone up much faster. Sea surface temperature all around India has gone up much faster than the land surface temperature. And the results will come to that. The results are much higher moisture content, intense rainfall events, and we don't need to remind how intense rainfall events cause disaster. We are very fresh in the Wayanad disasters. Himachal is happening. Uttarakhand is happening same way. Wayanad just happened. So we know what it happens because of intensification of rainfall. But that's one of the clear consequences of very high sea surface temperature, which produces lots of moisture, puts up a lot of moisture in the air, which is brought into the land. And once the moisture is there, it has to come down as rain. So those kind of events are happening. But this has other consequences, like much stronger storms, because the more is the water vapor that goes up in the air, like our vehicles and our engines have petrol or diesel or aviation turbine fuel as their fuel or energy source. The storms have moisture as their energy source. The more the moisture in the atmosphere when the storms form, the more the powerful, the storm will be more powerful. And that's exactly what is happening. And I will come to what has happened over the Arabian Sea and the western coast of India. But let me come to the third major point. Apart from when we talk about the Indian landmass, it's not just land. There are a lot of water bodies, inland water bodies. And why I'm saying I'm isolating water bodies as a distinct feature, because a very large number of people depend on them. And they are also fundamentally the sources of water for cities, drinking water, irrigation, everything. You cannot drink or irrigate with seawater. So it's all inland water bodies and rainwater. That's what we depend on for right from drinking to industry, to irrigation, to everything. Except part of the cooling of industrial units and power plants, which part of this can be done by seawater. Rest all are based on fresh water, which are from inland water bodies. So in the inland water bodies, the temperatures have risen a little faster than what has happened in the Indian landmass. And as a result, a lot of inland water bodies have shrunk drastically. Some have disappeared. From a water body, they have become a landmass. So this has drastic impact on fisher people, on agriculture, and a lot of other things. So the fourth major issue or major pointer is around forest. If you have noticed that forest fires, the same rise in temperature is not just rise in temperature, because what has happened, and this has been found out by a long-term study by the India Meteorological Department, that the monsoon rains, as you all know, the monsoons give us something like 74-75% of our annual total water resources, something like 870 mm of precipitation, and in a year, and this 4 months, June, July, August, September. So what has happened to the monsoon as a result of the warming and the climate change is that the total amount rainfall over India as a whole has not changed drastically. There's minor changes from state to state. There are significant changes, but overall, there is no major change. But what had happened is the number of rainfall days has come down drastically. What used to happen around 30 years ago, 35 years ago, is that the amount of rain that used to come down in these 4 months were distributed over 42 to 45 days of rainfall days. Today, what is happening is 24 to 26 days, same amount of rainfall is coming down. So as a result, when it pours like anything. It pours cats and dogs. And in between, there are dry periods. So when it pours heavily, there are flooding, landslides, and all these issues. In between, there are dry and hot periods. And during these dry and hot periods, particularly in the forested regions, where due to the slope and the porous soil, the water do not hold too much except the trees roots and all, the forest floor becomes dry, and over a dry and hot period, if it gets drier and hotter, any small spark creates a big fire. If you have noticed, the state of Uttarakhand over the last 2 decades, the number of reported, so this is called reported incidents of forest fires. It's not that 2 decades ago there were not enough reports, but in the last 2 decades, the study says that number of forest fires in state of Uttarakhand has gone up by 45 times. And this is, I'm repeating this, it's not 45%, not 4.5 times, it's 45 times. It was 22 years ago, it was 900 something. And last year, 2023, it was 41,600 something. So this is a steady trend. The same thing has happened in Himachal Pradesh, same thing has happened in any state which has major forest areas. So except in very wet areas, like the rainfall areas of Western Ghat, the forest fires has not increased that much. But this has happened in a large part of the Himalayan areas and also other forests. The fifth area, which is extremely important for India again, is huge loss of snow and ice cover from the Himalayas. So this is again a continuous trend. Indian Space Research Organization has a study over this, which is a long-term study. The Space Application Center has done satellite imagery-based studies continuously. And it has been seen that over 24 to 25% of ice and snow mass, it's not only glacier, snow and ice mass have been lost over the last 40 years. And this means that the river flows, during the peak summer, the river flows are very good. But after that, the river flows goes down because the amount of snow ice melt that is available is much less. And that heavily impacts not only agriculture, but industry and the weather pattern that around that happens around those river valleys. So this is the fifth area that is of major concern, which is happening continuously. The sixth area I have already talked about, the erratic monsoon rainfall, the change in monsoon rainfall pattern. But there is another change that has happened. Often, this year monsoon was in time, but often it has been seen due to climate change, and this was predicted over almost 20 years ago, around 18 years ago, that the monsoon onset is getting a little delayed for many years. And monsoon, sometimes, though its onset is delayed, its progress, the monsoon progress is not uniform like it used to happen. Sometimes it stops, sometimes its progress is very fast. And this is also driven by the extreme heating of both the Tibetan Plateau and the northwest part of India and Indian subcontinent, that is Pakistan, India, Afghanistan, that part, which draws the monsoon towards the west. So this is the sixth area that has been happening, along with the intensification of rainfall and in between long dry and hot periods. The seventh area that I would like to point out is this has emerged as one of the major threats for people, working class people, and that is not only the heat waves. Heat waves used to happen long back. Even 30, 40 years ago, short periods of heat waves, 2-3 days of heat wave used to happen. But what has happened now is very large part of India, the entire Gangetic basin, starting from lower parts of Uttarakhand, Uttar Pradesh to West Bengal, and a large part of southern India, the number of heat wave days has increased drastically. And this is impacting the working class population tremendously. But I would like to quickly point out that what we are missing in this is when we are focusing on the heat wave, we are not really considering the real danger, which is the heat index, which is a combination of high temperature and high relative humidity, which is the real killer combination. Just the heat, that is the temperature. Heat means heat is a content, total heat content. We indicate it by temperature, 44 degrees, 45 degrees. I also remember 30 years ago in Delhi, when I came to Delhi 32 years ago, Delhi used to have 44, 45 degrees Celsius temperature for a few days. And people used to move on the streets. People don't die just by that kind of temperature. But if you have a combination of even 38, 40 degrees and a high relative humidity of 80, 85 degrees, and if you want to work, do physical work in that condition, you can die. Not only fall sick, but you can die. So this is a killer combination, and this is called heat index, and it's indicated by the wet bulb temperature. So this is one thing which has emerged as a great danger for the very large working class population in India. The next point that we want to highlight is obviously some of these I have mentioned. I've just touched upon this. The much higher number of climatic disasters. See, we face disasters of different kind. One is which has no connection with climate, basically the earthquakes. So our Himalayan belts and some parts of Western India and some parts of Eastern India, I mean Northeast India, which are again part of the sub-Himalayas, they are exposed to the earthquake risk. Many of these areas are in zone 5, the highest risk. Many of the areas, lower parts of Himachal, Uttarakhand, etc., are in zone 4, including Delhi is zone 4. So these are high earthquake risk, but these have nothing to do with the climate change impact. But the other impacts that are happening, extremely strong storms, intense rainfalls and flooding, including, I'll come to later, urban flooding, sudden storms, then sudden drought periods which go on for very long and very high heat. These are direct impacts of this climatic disaster. These we can call climatic disaster. Of course, there is another class of disaster, and there is always a mixture of development-induced disaster and climate change-induced disaster. Because if a climate change-induced disaster happens and you have maldevelopment in that area, your impacts will be much higher, which you saw in Himachal Pradesh last year in wide scale. This making a 4-lane road by blasting through the fragile sub-Himalayan regions from all of these. Then the Uttarakhand, the Char Dham all-weather road, and as a result, hundreds and hundreds of kilometers of road with the heavy rains, they caved in. Entire villages have been again like wiped out. Good thing is not so many people died, but a lot of people's houses were damaged. A lot of roads went out. A lot of agricultural property were washed out. So these kind of maldevelopment combined with climatic disasters, they magnify the climatic disasters, but the origin remains the climate change induced disasters. So these are areas that have major concerns for Indian subcontinent or South Asia. And along with that, one of the major issues, as the 10th issue that I want to highlight, is the sea level rise. And it's not only a sea level rise, because seas are rising slowly, around 4 millimeter per year. But along with that, what is happening is, combined with the stronger storms, the storm surges are taking saline water farther inland. Agricultural land, other lands are getting saline. Drinking water sources and ponds of fish cultivation ponds, all of these are getting saline. People are losing their entire means of livelihoods. So sea level rise along with salinity ingress driven by stronger storms and storm surges. This is another major area. And let me connect this with the 4, as I said, 4 different kind of geographies that India is facing. The climate change impacts, climate change induced impacts are suffering most from are, one, obviously in the Himalayas and the other mountain areas. Second is the coastal areas. The Himalayas, around 2,500 kilometer stretch from the western part to the easternmost part. The coastline, just across the coast, it is 7,500 plus kilometers. But if you go into details of the contours, then even more. So there is a very large population which resides, far larger than resides in the Himalayan belt. A much larger population resides in the coastal belt within 50 kilometers of the coast. So that is the second most important, or second area of most impacted regions. The third area is, which is not coming so much into news, is the central Indian dryland forests, where a lot of changes are happening because the forest, not only because of forest fires, a lot of invasive species is appearing, a lot of this forest die out is happening, forest thinning is happening. And this is not, I'm not talking just about development-induced malpractices, but this is also happening because of climate change. And the fourth area, yes, the fourth geography that I wanted to highlight is urban areas. As I said, this is not exactly a geography by the geographic sense, but over the last decade and a half, urban areas are facing more and more severe kind of climate impact. And that we have seen every year: Delhi, Mumbai, Chennai, Bangalore. These are mega cities which have suffered tremendously. Then smaller cities like, if you know, uh, uh, even in the Sahyadri rain shadow areas, these Miraj and Sholapur, Kolhapur, all these areas which are comparatively dry areas, they got flooded in 2021, I think, massive rain and flood. And this is now happening in multiple cities. And this is not only the urban flooding, but lot of other impacts with where the urban poor lives, their urban impact of more urban slum fires, then heat index and heat wave of a localized nature that I'll come to later on. But these four geographies, in a sort of geographies that we are seeing in the South Asian region, we are suffering the climate change impacts the maximum. Now, out of these, as I said, 10 major pointers I did, where is the climate impacts happening, what kind of impacts are happening, and then the four major geographies. Let me go a little bit to not to limit. Of course, when we are talking about climate change impacts, it's mostly we talk about from an anthropocentric view that humans are being impacted. But we have to keep in mind all the time that as we get impacted, because the geographies get impacted, the forest gets impacted, rivers get impacted, the mountain slopes get impacted, huge number of species, other species, both animal and plants, they are also displaced and impacted in a very large scale. So when we talk about impacts, we must always keep in mind that this is happening not only to us Homo sapiens, but all other species of life that live in the same geographical boundaries. So keeping that in mind, let me come to the communities and the communities who are suffering most, and what kind of changes, what kind of impacts they are suffering from. And when we talk about different kind of working communities, obviously farmers is one community which is by being the largest, because as government data says, roughly 14.5 crore to 15 crore families are farming families. So if you add multiply by 5, it's a very large number. It's close to 50% of Indian population. And as Bhargavi said, the government data says roughly 45.5% of people get their livelihood and their income, employment and livelihood from farming. Employment as farm laborers and other workers, and livelihood as farmers. So as farmers and suppliers of those, etc. So 45.5% or 46% of the population gets their livelihoods from that. So in the farming sector, one of the major impacts that has happened, and as I mentioned earlier, is the erratic rainfall. Because farming in India still around, I think a little over 50% of farming in India is rain-fed farming. Irrigation is available to less than 50% of the total farm. Roughly around 155 million hectares of land is actually arable, being cultivated right now, 155, 156 million hectares. Roughly 50% is rain-fed. There is no provision of irrigation. So there, unless the rains come on time, rains are not excessive. After the rains, when the rains need not be there, it should be dry. Again, when you need more water, there should be some rain, which was the periodic regularity for not only decades, but centuries. And as I said, almost the whole of Anthropocene, except a few erratic years, we had this regularity for almost last 9 to 10,000 years. But over the last 3 to 4 decades, this regularity has completely been destroyed. And this because of climate change. Because as we said, that what we didn't do in 10,000 years, the temperature was within 1 degree plus and minus here and there. We have crossed 1.48 last year. So all this regularity is now getting disturbed. So this is one of the major impacts, the irregular rain, extremely heavy rains, hailstorms, not hailstorms, but normal storms, which are much more stronger. And as we know, if there is, as I said, if there is more moisture in the air and if the temperature is higher, the storms will be higher. So the losses by the storms, losses of the crops are getting higher, and which was predicted for quite long time. In fact, if I recall, I have been writing about this for the last 15 years, that these are the kind of things that are going to happen. Earlier, 15 years ago, I used to write these are going to happen. Today, if we say these are happening every year. The second major impact that's happening, and that's not talked about as much, because the storms and extremely heavy rainfall, flooding, these losses are talked about a lot. But the second point that I will highlight is not talked about much. It's a very general rise of temperature, particularly the nighttime temperature. And for many crops, including wheat is very sensitive, rice is a little less sensitive, paddy is a little less sensitive to that, but wheat is more sensitive. Several crops are very sensitive. If during the ripening season, if the nighttime temperature is more than 1.5 degree above, which is normal for that, your kernel formation gets badly impacted. That means you still have wheat, but the wheat grains will be much smaller. So your productivity will be much less. The price of that wheat as a quality will be drastically lower. So this is happening year after year. And if you recall 2022, this happened across national scale. In February 2022, and this is public knowledge, this is there in the public domain, there was a prediction for a bumper wheat harvest. Even the Secretary Ministry of Agriculture said the same thing. And I was moving around in UP and Bihar areas. The farmers were very happy. March, April, 3 heat waves happened, and the wheat production crashed. Indian government had to ban wheat export, and Indian wheat export also supplies a lot of 18 countries, including Egypt, Bangladesh, etc., etc. So this kind of serious impact, and the small farmers who also depend on selling the wheat at that point of time at least the reasonable price, they got a big hit. And a lot of suicides actually are happening because of these crop failures. And crop failures, because the input costs are high, they have to take loans to cultivate. And if they cannot recover that, they cannot pay back the loan and the harassments, and you know the whole chain, how it happens. So this is one impact that is happening increasingly, and it's not being talked about much, that very gentle rise of nighttime temperature during the ripening season. And this is called slow onset event. Like if we are talking about extremely heavy rainfalls, flooding, or some big storm or a cyclone, these are climate extreme events. But this slow rise of temperature, slow rise of sea level, these are called slow onset events. These are a larger impact over a longer period of time. And these are not being talked about too much, not being considered too much. The third impact that the farmers are facing is spread of invasive species. And this has also now spread quite a lot. In fact, the different communities that I work with, a lot of people are reporting different kind of weeds that they have never seen before. A lot of people have reported, even from Himachal Pradesh, from an altitude of around 2,700 meters in the Dhauladhar range, people have reported insects and weeds, grass-like weeds, which they have never seen before in their lifetimes. And that means because of the temperature rise and the change in climate of those regions, these invasive species are able to migrate there. And this is causing loss of local species. So this is another major impact that is increasing, and this needs to be taken care of. The loss of crops due to disaster we have talked about, and that's one of the, in fact, 2015-16, we from our another collective called Monsoon, we did a study in 8 states of India, in one district each, 5 panchayats, and we found there are 3 major impacts everywhere small and marginal farmers are talking about. And these 3 were: 1, extreme disasters, extreme events, which are having their crop losses. The second was in attack of wild animals and feral animals. So this has increased drastically. This is again when we started investigating more and more states and more districts started reporting that this is happening. And today we are seeing large number of areas where farmers bordered by forested areas. Just few days ago, I came back from Himachal Pradesh. It's very lush green areas. The person whose auto rickshaw I was traveling by said, we have stopped farming in our land for the last 4 years. And the reason is the wild boars, they come and destroy their crops whenever they start getting ready. And this is happening in Uttarakhand, Himachal, Kerala, Madhya Pradesh, lot of states, Jharkhand, Chhattisgarh, all the 8 states reported these two. And these two also are related to climate change, because because of drying out of forested regions, of course, this has got a complex impact, because we are also fragmenting forest. We are cutting down the wild habitats, both by urbanization and industrialization and roads and other things. So this has a complex impact, but climate change also has a role to play in that, of drying out forest, which is, once it is fragmented into smaller areas, it dries out quickly and dies out quickly. So once the forests become less able to provide food and water to these animals, the wild animals, and of course, over the last several years, the problem of feral animals, because farmers cannot feed their cows and bullocks beyond a certain period. So they are leaving them leaving them on the streets or in the open. And these, after a few days and months, they are becoming feral animals, because they also have to live and eat. This has become a major disaster for farmers almost all across India. Wherever there are little bit of greenery and wilderness are left, where these animals can go and rest, nilgais, wild boars, monkeys, and feral cows and bulls, all of these, they have become a major menace. It's not their fault, it's our fault, but it has become a major challenge for farmers. So this is the 6th aspect which we have seen. And the 7th aspect on the farming area that, just remind me of the time. Priyanka, if just remind me of the time, 10 minutes.
Sure, sir.
Okay.
Yes, sir.
So the 7th element is very risky working condition, which I will not go into detail here because of the heat and humidity and the conditions, which I will cover quickly when I talk about working class people and their challenges. And the last point there are other points, but I quickly want to round up. Last point is massive loss of soil moisture and organic carbon, or organic soil carbon. These two have been lost in massive scale over the last 30 to 35 years. And as you know, if the soil loses organic carbon, soil carbon and moisture, this soil becomes basically dead, just the holding element. So this has happened over the last 30-35 years in a very large scale. In fact, there are studies which showed that in the 50s and early 60s, central Indian soil had something like 0.9 to 1% of soil organic carbon. Today, it is 0.5 to 0.55, almost half. So this is a drastic loss, and there is a drastic loss of soil moisture during these dry periods. So these two are having serious impacts over farming. Let us quickly come to the working class population. Here I will not go into details because there are clear impacts and there are clear agendas how they can act. One of the major, and if we calculate how many people are impacted, there are 7 to 8 crores, rough estimate, construction workers in India, around 3 crores plus street vendors, 2 to 3 crores rickshaw pullers, similar number porters and others, and there are similar other working class people. So, and if you include some 14 to 20 crores of small farmers or farm workers, this will become 45 to 50 crores of working class population who have to work for earning a livelihood and sustaining themselves in conditions which are both high temperature and high humidity. So this heat index during the working season has become a major challenge, and this needs to be addressed in an quote unquote war footing. We don't like war, but that's how it is.
Sound is not coming.
Am I audible?
Yes, sir, you're audible.
Okay, so that is one thing that needs to be taken as a challenge and addressed as a top priority. I'll not talk about war footing, as a top priority, because this is impacting nearly 50 crores of working class population, very, very badly. And the projection says, it's not only the IPCC projection. If you look at the Indian Ministry of Earth Science studies that was released in 2020, all of them are showing that by 2050, the number of heatwave days and the increased moisture, these days are going to increase by 8 to 10 times. So this will make roughly 30 to 35 days in a year non-workable, non-physically workable for a very large area of India. And which means a very large number of people will not be able to earn their livelihood and not be able to sustain themselves. So this needs to be taken up in a very sort of high priority. The second is the urban, because of lot of urban disasters, urban floodings have increased tremendously. Urban slum fires, for the same reasons. If you know, lot of waste workers and recyclers, they live in the urban slums, and they store a lot of inflammable material, including a lot of plastics, including styrofoam, polyethylene, and all of this, polyvinyl chlorides. And these are highly inflammable. And they also store glass and other things. The slightest, when there is a dry and hot period, the slightest spark can create a massive fire, and this has actually increased. The urban fires have increased quite a lot in this kind of situation, which again is not in the radar of the disaster management and this kind of framework. Let me quickly go into the third major geography, which is the coastal area. The coastal areas, as all of us know, are suffering from multiple impacts. One, everybody understands, because that is the biggest impact, most visible, is the increased number of cyclones and more intense cyclones. See, historically, the Bay of Bengal was more prone to cyclones than Arabian Sea. Arabian Sea was not very prone to cyclones earlier. And because of two reasons. One, the Arabian Sea surface temperature was comparatively lower. Second, the wind shear was comparatively higher. So the Bay of Bengal on an average, had a big cyclone, a very big cyclone, category 4 and above every year. Not all cyclones go and come and do landfall in India. Not all cyclones do landfall in land also, do landfall. Some cyclones originate and end in the sea also. But cyclones which do landfall, either India or Bangladesh or Myanmar, those are the cyclones of concern. So these kind of cyclones have gained in strength in the Bay of Bengal dramatically. And the same reason, because the sea surface temperatures is much higher, it's giving much more fuel, moisture. So the cyclogenesis has increased and the cyclones have become stronger. But the more surprising and more sort of alarming thing has happened over the Arabian Sea. Over the last little more than 2 decades, the number of big cyclones in the Arabian Sea has increased by 52 percentage points. That means 1.5 times, which has not happened in the Bay of Bengal. Bay of Bengal cyclones have become stronger, a little bit more, but not significantly more in numbers. But in Arabian Sea, strong cyclones have increased by 1.5 times, more than 1.5 times. And if you go along the coast, I have been working with many of these communities in Bangladesh, in West Bengal, Odisha. I have seen in the eastern coast, because it was exposed to cyclone historically, their preparedness, both of the communities and of the government, is higher. If you go to the eastern coast, you will find cyclone shelters every 7-8 kilometers or 5-7 kilometers. You will see people ready to evacuate, people knowing what to do, though people still die because of some mistakes or some unfortunate happenings. But in the western coast of India, cyclone preparedness was historically much lower. And there is a reason, because it didn't face those kind of cyclones. And if you see the losses that the western coast suffered by cyclones like Nisarga, Taute, etc., which much less losses have been faced in the eastern coast, you will find that this is actually true. Only now there are projects and preparations that cyclone proofing, like some few districts in Maharashtra, coastal districts, they have started projects of cyclone proofing infrastructure, not cyclone proofing the communities, but cyclone proofing the infrastructure, etc. Some World Bank funded, some GCF funded. So this kind of projects have started. But the overall preparation in the western coast for facing cyclones and reducing the losses, getting ready for cyclones, it's much less. So one of the major impacts is increased number of cyclones and more intense cyclones. But along with cyclone, what I already said is the salinity ingress. Because of stronger storm surges, more saline water getting in, more land being lost, more water sources being lost to salinity, and people losing their land and livelihood. Because if they are the 2021 cyclone after the Amphan, then when it happened in West Bengal, just 2 districts, they lost 15,000 fish producing ponds, because all the ponds got saline water and the fish died, and they could not quickly evacuate the water. So the ponds were inoperative and inactive, non-productive for over 2 years. On the 3rd year, they started again after 2 good rains. So this kind of impacts are increasing very strongly in the coastal regions. The other thing that has happened for the coastal fish workers is that, and this has been reported by coastal fish workers in our discussions when we held workshops for them by the NFF, National Fish Workers Forum, and others, that because the meteorological department, the India Meteorological Department, is giving cyclone warnings, which they have to give. Repeatedly, cyclone warnings are given. Okay, the wind velocity will be high. Don't go out to the sea for next 4 to 5 days. And this comes once, this comes twice, this comes thrice. And over a season, and the cyclone season, if you know it very well, cyclone season is from around mid-April to mid-December with a break in the monsoon. During the monsoon, there are less, during the strong monsoon season, there is less chance of cyclone because of the wind patterns. So what has happened is, if you have 4 to 5 such warnings in a year, that means 20-25 days of your fishing in the coastal waters or in the marine fishing is off. And that takes away a huge chunk of your earning, because coastal fisher people cannot go and do fishing throughout the year. There is a fishing season, there is a fishing ban season. So all these they have to follow, and they do follow. So this is also hampering their livelihood and their earning potentials tremendously. The last factor that I will like to mention, there are several other factors which is happening, and the acidification is definitely one major impact. That acidification has happened because of the carbon dioxide. This is not an extreme event. This is again a slow onset event. It's happening very slowly, not being reported much, but due to the increased carbon dioxide concentration in the ocean, because if it is in the air, it gets, due to the churning of the ocean waters, it gets absorbed in the waters. So carbon dioxide getting absorbed in the ocean waters, it's getting more acidified, pH value is going down, and as a result, fish productivity of the ocean, those areas have really gone down. And the connected thing is, because the temperatures in particularly central India and southern India, the coastal states, central part of Maharashtra downward, and that side Andhra Pradesh downward, because the temperatures are now higher than it used to be 20-30 years ago, lot of fish are migrating north to the cooler waters, and that has impacted the fish catch drastically. And as a result, the coastal areas close to coast, these areas are getting depleted of fish. And out of fisher people, there is a class which do not have access, do not own, or do not have access to powered boats. They have rowing boats for fishing, manually driven. So these people, they cannot go out to the outside water. They cannot go to 10 kilometers or 5 kilometers. They keep close to the coastal areas, to the shore, and they have lost out dramatically. So these are impacts on the coastal fisher people. I have talked about the inland fisher people, how drying out and temperature rise of inland water bodies is drastically impacting them. And I'm not talking about the development impacts at all in this session, because that has been talked about a lot. But just to keep in mind that these impacts are always compounded by the maldevelopment that we are seeing everywhere. So how much time do I have?
So we have time. You can.
So I'll just quickly mention, then I'll open up for questioning. Quickly mention not all sectors, but major sectors of economy, which both impacts and are being impacted by climate change impacts in India and South Asia. One obviously is the electricity sector. As we know, India's roughly 49% of capacity is coal-based. Roughly 72-73% of our produced electricity come from coal power plants. So coal obviously is the major contributor to climate change, but it's not only a contributor. Coal and nuclear, these two are also heavily dependent on water for cooling the power plants, because the condenser water has to be cooled. The water, once it gets steam and drives the turbine, then it has to be cooled to being water, to become water, cool water again, and to be recirculated. So they need a huge amount of cooling water. And this cooling water is taken generally from inland water bodies, rivers, or very big lakes. Except the coastal power plants, all power plants take from rivers. Generally, few takes from big lakes. And this has been impacted. Not only they are impacting the water temperature where the fish and other things are dying out, but the power plants are suffering because these water bodies are drying out. And in the summer season, in the dry and hot season, these power plants don't have enough cooling water. It has been reported repeatedly that several power plants were ordered and they had to cut down their production because there was no cooling water. There was no shortage of coal. There was no malfunction, but there was no cooling water. And if you count the amount of water they lose by cooling, roughly for 4,000 to 5,000 kg of water is lost by evaporation for every megawatt hour of power production in the coal power plants. So they lose a huge amount of fresh water, plus they need 10 times that much water to be recirculated. That means the water comes in, cools the condensations and go back. So this water is not available during the hot season. So the power plants, 72% of our power, I'm repeating this, our electricity comes from coal power plants. But during the hot and dry season, when you need the electricity the most, these power plants have to cut down their production because there is no cooling water available or very little cooling water available. So that's one direct impact. The electricity sector in India has evolved, no doubt about that from around 15 years ago, we have roughly 49% of coal power plant coal capacity, that is the installed capacity. But we have almost 85 gigawatt of solar, 46 gigawatt of wind, around 47 gigawatt of hydro. I'll not talk about hydro, its impacts, etc. That's another matter. But we have this kind of thing, which is now, even the hydro is now categorized as renewable. So the government can say we have nearly 190 gigawatt of renewable capacity, which is over 40% of our installed capacity of around, installed utility capacity of India is around 447 gigawatt. Out of that, almost 200 gigawatt is now categorized as renewable. But again, this is an installed capacity, not the generation, because generation from solar, wind, even hydro is much less because of their lower plant load factor. They don't generate for 24 hours. They generate only when the sun is shining and the wind is blowing. I'll again not go into the pluses and minuses of solar, wind, etc. There are a lot of misunderstanding. A lot of activists also talk about this. But there are I'm just talking about the reality and the facts that in the power sector. If we have to really tackle this shortage of water, and that's impacting availability of electricity when electricity is required most, because adaptive measure, if you have to adapt to climate change, extreme heat index, that is the combination of heat and humidity, if you have to adapt to that, you need energy. You need to supply energy, because people cannot be saved without proper cooling in those kind of conditions. People cannot work without some sort of energy inputs, either by fans or by coolers, or in good cases by AC. There are a lot of cases where people can be saved if you have good cooling arrangements in those kind of areas. So that is one thing that we have to need in our electricity sector, that our electricity sector should shift from which are both causing climate change and are impacted heavily by climate change to which are beneficial in both ways. Other factors I'm not considering right now, and I'll not go into nuclear. Nuclear is actually for India is not very important in climate sense, because nuclear energy capacity is around less than 2% of installed capacity and 2.7% of the generation that comes from nuclear. So it's not a major factor. If we and the risk factors of nuclear are huge. So the only factor that I want to highlight is that the propaganda that has been made by the nuclear lobby that nuclear is climate friendly is actually not true. Nuclear cannot actually save from climate change crisis or climate chaos, because though over a very long period of time, if you calculate the carbon footprint per unit of power generated, nuclear will be coming less, but the embedded energy for building a nuclear power plant is very big. And that means the upfront emission for a nuclear power plant, building a nuclear power plant, is very big, very high. And MIT has done studies on that. Other universities have done studies on that it takes roughly around 15 years for a nuclear power plant to produce power to become better than a gas power plant or closer to neutrality. Gas is also not neutral, but to compete with a gas power plant, do better than a gas power plant, it takes close to 15 years. So 15 years is more than enough time that we have to do. We don't have 15 years to tackle climate change, because by that time, the temperature rise and the conditions will go beyond criticality. And that is clear, very clear in the IPCC reports. The second sector I want to highlight, I'll come cutting down many other points. The second sector I want to highlight is transport and mobility. In India, as in many other countries, transport sector is massively dependent on oil, petroleum. And in India, the annual consumption of petroleum is around 235 million tons. Roughly 50% of that goes into the transport sector. So the transport sector is both a cause of climate change, and as a result of climate change, there are issues that are happening because of our kind of transportation infrastructure. The railways are far better in terms of both energy efficiency, that means whether a passenger kilometer carried or a ton kilometer carried of luggage or a passenger kilometer carried of human beings, the railways are one of the most efficient in terms of energy, in terms of emission. But what we are seeing in India today, what we need to see from the climate angle, is that there is a very high emphasis on road transport and high-speed road transport, including expressways, highways, which is a complete reversal to any sane climate action. So this is one area, and the danger in being dependent on this petroleum-dependent transport is also, out of the 235 million tons that we consume now, and it's projected to increase to more than 2.5 times by 2040 by government data, 83 to 84% of the petroleum is imported. So both in terms of foreign exchange, foreign relations, all of these we are tied up, and that also has a climate impact. So I have talked about the agricultural sector. I'll not go into detail of that. Let me now open up for any questions, then I can take up further. Because I wanted to talk about the governance mechanisms, but let me give a break because it's becoming too long for people to probably keep a.
Thank you so much, sir. Like sir said, if any of the participants have any questions regarding the session so far, you can put your hands up on the Zoom, or you can type your questions in the Q&A box or the chat box as well. So we'll just give it a couple of minutes if some questions come in.
Okay, then 5 minutes, 7 minutes, I'll try to cover some of the governance mechanism which exist and where one can intervene.
Sure, sir. Sure. Sir Bamadev sir, I think, has a question or a comment perhaps. Sir, please go ahead.
Nice to meet you at this juncture, and very important, session, first session. And Mr. Rao and Soumya Dutta, he explained much on, the consequences of climate change in South Asia with a reference to India. And well, very interesting and, the very comprehensive, thought-provoking lecture. And I won't like to comment. I would like to add something, and melting of Himalayas, gradually affecting the ecosystem of, South Asia, and even livelihood residing in Himalayas and upper hill, as he already mentioned in Uttarakhand, so happened, in Nepal, due to heavy rain, Kathmandu was also flooded, and the people died, And one thing I would like to add for this session, that is, migration due to climate change that is happening in South Asia. People where people are choosing, the cozy place, to live in, live in the countryside, and the hill and upper mountain has remained barren in the case of Nepal due to climate change and the cause of disaster in Nepal, and the impact of climate change in economy and society, the cost of impact is going to increase, the macro impact, as he already mentioned. And I agree with him, that, Himalayas, ocean coast, central Indian dry land, forest, urban areas, that are highly impacted, by climate change, and very comprehensive. I enrich much from his lecture at this moment. And lastly, the farmer, artisan, and the indigenous community, they are mostly affected by climate change. And I think, it will be tough to attain the sustainable goal, that has been committed by we South Asian countries, at this juncture. If such a type of climate change, rapid climate change happening in South Asia. Thank you for his lecture. Nice to meet
Thank
you.
you.
Namaste.
Thanks. One question from a participant that I could see is the how the dumping of waste affect climate change. So I couldn't follow the name. So the dumping of waste means, see, waste has multiple categories. You can have what we call construction waste that do not change, that do not impact the climate. But a major part, particularly in South Asia, a major part of our waste is called wet waste. That is vegetables, vegetable peels, waste food, many of these. And if these are dumped in a waste site and it builds up one after the other, like it is happening, it generates methane because it goes under. There is very little oxygen. So in an anoxic atmosphere, the methanation takes place. And methane is a major contributor to climate change. So these dump sites of waste, particularly the vegetable wet waste, the organic waste, that creates a lot of methane. And most of the dump sites, you will find huge amount of methane coming out. So that is one major concern. There are methods to take out the methane. There are in many countries, pipe networks in these dump sites have been done. Of course, starting with the dumping first and then addressing this called tailpipe solution. This we don't recommend. But once you have created, if the problem is already there, then to address this, taking the methane out and even burning that methane to get energy is a better solution than let the methane seep out and go into the atmosphere. Because in the short run of 12 to 20 years, methane, molecule per molecule, methane is 85 to 87 times as powerful a greenhouse gas as carbon dioxide. So it makes sense to take out the methane from dump sites and burn it for energy. Is there other question?
Yes, sir. We have a couple of questions here.
Can you just read them?
Yes. Atika Hassanji is asking, Atika ji, would you like to ask your question yourself? If you wish, you can unmute and ask. Yes.
Yes. Am I audible?
Yes.
Yeah, thank you, sir, for the wonderful discussion points. My question mostly pertains to the issue of climate-induced displacement that would be happening. A major of the impacts that you have talked about will be leading to that as a consequence. So, can you also provide some comments on that issue within the South Asian region, or maybe specifying with India, or just yeah?
Right.
Thank
So
you.
what you said is what your question said, that climate-induced displacement will be happening. Actually, climate-induced displacement, or if you call climate-forced displacement, is already happening, which they are not given status of refugees. If you go to Odisha, there is a district in Odisha called Kendrapada. Uh, Something like 12 to 15,000 families of that district have already got displaced, and they have moved to small town cities and maybe even Bhubaneswar, Cuttack, etc. Because the sea level rise and what are the two issues I talked about: sea level rise and the salinity of the soil and water in those areas. So they have lost their livelihoods. The land is non-productive, and their water is non-drinkable, non-potable. So they had to move. If you go to Sundarbans area of West Bengal, I'm not talking about Bangladesh. A lot of people from Bangladesh, Sundarban, have also got displaced. I am working also with Bangladesh communities, and I have seen these people. If you come to even within Indian boundary, political boundary, if you go to West Bengal, Sundarban areas, after the two cyclones, Aila and there's another big cyclone, something like 800 to 1,000 families were forced to leave all of their land and house, and they migrated. And it was an accident that I found them more than 600 kilometers north in the Tista Basin. They have, when I inquired with the people who are living in lowland areas of partly part of the year, these lands get underwater, part of the year they are land. And they do one-time cultivation and they move on boats. And when I found that they are from Sundarban areas, they said, our question was, why did you migrate so far away and leaving everything? Their input was, after Aila, for 6 years, there was no production from our land. Our water was saline. Our pond got destroyed. So what do we do? So this is actually happening in very large scale. And the projections are that, and the Sundarban Delta, the Bengal Delta, both in Bangladesh and India, is very flat. The gradient is very low. So a little bit of sea level rise, the water comes far inside. Similar is the case in Gujarat's Mundra coast. If you have seen Gulf of Kutch, Mundra, Mandvi, those coasts are very flat. With a little bit of tide, kilometers of land goes down and comes up. So in those areas, with a little bit of sea level rise, which is happening, lot of people are already losing their land, losing their homes. If you go to Kerala, I'm not talking about the mountain areas, the Wayanad and other areas. Go to coastal areas of Kerala, not only the sea coast, but also the backwaters. Lot of houses in the by the side of the backwaters are now inundated for 3 to 4 months a year. Lot of people are now leaving those houses. Some people have spent lot of money in actually increasing the height of the house by paying engineering firms which have now specialized in this, but not everybody can do that. So this climate forced migration is already happening in fairly large scale in Indian areas. Yes, the Wayanad, of course. Is there another question before that, Priyanka?
Yes, sir, we have a bunch of questions. Induji also has a question related to waste. Induji, if you want, you can ask yourself.
Ma'am, it's already answered.
Okay.
Okay. So
The next one was in relation to the health concerns. How it amplifies the this thing pathogens.
Right. See, there are 3-4 areas where climate change impacts the health. The health and climate change areas, if you are interested, there is a whole book prepared by WHO on this, health and climate change. And there are studies done by other groups. There are 3-4 areas which are most important. One, in areas which had no vector-borne diseases, particularly in the lower Himalayas, there now lot of vector-borne diseases are being seen because mosquitoes, etc., are spreading. The second thing is in areas where viruses and bacteria were not able to actually grow much colder areas, very cold areas. Cold means, say, in the winter, they are below zero sometimes or close to zero. Those areas, viruses and bacteria, lot of pathogens were not able to grow much, particularly those kind of things that cause diseases. Now they are becoming more and more prominent. The other area that is happening, that is becoming much more important, which I already talked about, is the impact of heat wave at heat index. This has become a major health impact. And if you talk to doctors, they are clear about the heat. Many of them are clear about the heat impacts, that is the temperature impacts. But many of them are not clear about the heat index impact. And that's why when they advise, even when the government gives advice that you drink a lot of water, that's not a good advice for a high heat index. Because even if you drink a bucket of water, it's not going to cool you down, because the ambient moisture content is very high. So your skin will not evaporate the perspiration. So your body will not be cooled down. And anyone with a problem of heart and lungs and kidney, these three, any pre-existing condition, are far more prone to serious ailments because of heat index, both high temperature and high humidity. So this is emerging as a major area of health impact. And this will be, that's why I said, this needs to be taken on as a high priority impact area and addressed. And this can be addressed comparatively easily.
Thank you, sir. Yes, so we have another question.
Why not?
Yeah.
Yes, actually the Wayanad landslides, there are, unfortunately, there is some controversy which has already been created. Some very senior environmentalist, I have also worked with him, Madhav Gadgil. Lot of Kerala environmentalist scientists are really saying the amount of rainfall that happened in Wayanad in those two areas could not have been predicted, had not been predicted by IMD, could not have been, not predicted by IMD. Second, if you see how landslides happen, of course, there is a little bit of contribution by so-called maldevelopment. People have made settlements there. People have did toe cutting. One of the no thing in the hills is toe cutting. If you do toe cutting, any heavy loading of water on that sloping surface is likely to slide down. So that's a simple primary science of hill slopes, and that people don't know and people have not followed. But the amount of rainfall, 400 mm plus, that has happened over 400, some 670 mm plus over 2 days, there would have been landslides even if there was no toe cutting. Maybe the disaster would have been smaller if there was no toe cutting, no clearing of greenery, but there would have been landslides. And these landslides have been happening not only in Wayanad, but yesterday or day before in Uttarakhand and Himachal also, because of the similar heavy rains. So as I'm saying, that Wayanad is largely by extremely heavy rainfall, but if intervention, wrong intervention by humans have not been there, the scale of disaster would have been less.
Thank you, sir. We have another question by Satviki Adla ji. Satviki ji, would you like to go ahead?
Yeah. Hello, sir. Thank you for a very engaging session. My question was about forest fires in India. From what I've heard, that most forest fires in India are human-induced, and the fires caused by natural causes are fewer. So how can we address this issue? What sort of mitigation strategies are required to be adopted for this? And how likely is it that we will get into a situation such as the bushfires of Australia or wildfires in America? Is a similar scenario possible in India?
See, this the actual scenario is not very clear. What is the primary cause? There are some fires which are caused by negligence, by people throwing a lighted matchstick after taking a cigarette or bidi, etc. But the forest department is known to blame people regularly. Forest department keeps saying that people have started this. People do light fires. See, after the winter, when a lot of leaves fall, and this is, I'll explain the case for Himachal, Uttarakhand, and entire sub-Himalayan belt or lower Himalayan belt, because this is also created by the forest department. See, the forest of cheer pine was not fully natural there. The cheer pine had been brought there from the British time, and even the forest department encouraged, even the independent India's forest department encouraged and spread that. Cheer pine has a characteristic that is needle when it fall, they are highly, when they dry out, they are highly inflammable.
Right.
So the condition for a good fire has been created because we have replaced a very mixed forest. Earlier, similar areas were having mixed forest, including a little high altitude, you have a lot of oak. Today, even at a 5,000, 6,000 feet, you hardly see oak trees. So the condition for creating a fire, forest fire, has been contribution of the forest department, not from today, but from the British time. So that's one. Second is, yes, people do try to clear the litter, leaf litter that falls, and they have this idea that this will create more fresh grass so that their animals can have better grass. And that is a practice being done for hundreds of years. What has happened today is now the habitations are much closer to the areas that people used to use as a pasture land and others, forest lands. The habitations are close by. So the moment one fire goes out of control, they create havoc. So that's one thing. But the second thing is what I earlier said, the change of rainfall pattern of having intense rainfall and then having a long period of dry and warm number of days, that has also helped. And when the wind blows strongly because of the friction, lot of the fire starts on their own. And these fires are not lit by people. In fact, the other factor that I would like to just mention here, which is a social factor, that by not giving the forest rights, by taking away the forest people's right to their forests earlier, now by denying people the forest right, lot of people have got alienated from there. I have heard this same comment from a lot of communities that I have interacted with. They said, we don't get anything. Even if 2 trees, 3 trees grow on my tree, my land, I will not be able to cut it. The forest department will not give permission. If the forest fire burns, what do I lose? Why should I go? I stake my everything to go and sort of extinguish the fire. Earlier, because people had access to forest wood, other resources, fruits, everything, they were having a direct stake in saving the forest. Now this alienation has happened to a large extent, and one solution is giving the forest rights back, which is now law. But the government is not following the law, which is Act Parliament passed in 2006 and operated or operationalized in 2008 January. But the government is not giving people the forest rights back. Once they give it, people will act more responsibly. They will take initiative to extinguish forest fire and not to light fires. But part of this is true. Part of the fires people do light, but part of the fire also go out when the forest department try to clear the leaf litter by burning. Forest department also do preventive burning.
Right. Thank you, sir.
So we have a follow-up question from Astha ji. Astha ji, please go ahead with the question. Yes, please go ahead. I'll read it out then, sir. How can the government and forest department manage the spread of invasive species like lantana and Prosopis julifera?
See, the lantana is very old. Lantana started spreading much before climate change became in Prosopis julifera also. But there are a lot of other also invasive species. So let us talk about the invasive species as a whole. One major area is we even don't know what kind of invasive species are spreading where. So that's the first step. Like once I was talking to some farmers group in north of the Ganges in Bihar, north side of the Ganges, and they showed me this kind of kali ghash. In their terminology, it's a kali ghash. It's a very dark colored grass kind of thing, which they said we have never seen, even our fathers, grandfathers have never seen. So one thing is to identify. Second, the conditions that are being attained there. See, if we invasive species, if it is a plant species, and we generally called it a weed, nothing is actually a weed, but let's accept that terminology for a time being. It needs certain conditions of climate, it needs certain conditions of soil, and it needs certain conditions of nutrition and all. So if we know what species are invasive, what species are invading in those areas, then we can see what kind of soil treatment we can do so that this species probably will not be spreading too much or will be controlled. Because mechanical control for both Parthenium, Lantana, etc. have really not worked because they are extremely labor intensive and these species spread very fast. So many of these species have these characteristics because they are going into a new territory. They have very little competition, and this is not only plants. There are invasive animal species which are also spreading. So first step is to do studies to understand which kind of species are spreading where and how, and then we can devise countermeasures. But ultimately, all countermeasures will fail if we are not able to stop this rise in temperature and climate change, because ultimately this will go on and we'll be only responding. So that's the ultimate thing. But in the interim, we have to respond to these problems one at a time.
May I add on this, sir?
Yes,
May
please.
I add on this? In the case of Nepal, you know, as Rai, she put the question, in the case of Nepal, the community, they made aware, how to cut such expanding plants in the forest line, and some community they are making briquette, to instead of coal like that, and the people are encouraged to make the briquette like that, and they are selling to the market too, and the demand of briquette in winter season, that is increasing, in such mechanism, too, we can reduce the expansion of the plant, aforementioned plant. Thank you very much.
Actually, this kind of thing has happened even in India. Like when I talked about the pine needle, they have been made into fuel briquettes. There are machines available for that also, but that will not solve the primary problem, because if we increase this, then we will have a need for large amount of that particular invasive species. That means that invasive species will be actually encouraged by local people at the cost of local species. So this is not a fundamental solution. This has been done in many places, but this is not a real solution.
Thank you, sir. We have another question by Sudakshana Ghoshji. Sudakshana ji, would you like to go ahead?
Yes, thank you so much, sir. Very, very insightful in the way you have put the numbers, the statistics. Puts a lot of things in context. I wanted to
try to keep down the numbers quite a bit.
Yeah, but it was very contextual, sir. It was very the way you explained it. It was the context was coming out in terms of the impact. So my question, it is maybe it has got a much bigger scope. But since you summarize the issues so succinctly, I wanted to get your perspective in terms of the current approach to economic growth and development is always focused on growth, and it still continues to be resource extractive in nature, right? So what are some of your thoughts around the current industrial activity? What kind of changes are necessary to sort of arrest and then eventually reverse the trend of this rising temperature?
See, there is a little bit of confusion in many circles about growth and all. I also fundamentally I see infinite growth in a finite world is not possible, that everybody understands.
Yeah.
But it seems that economic machine do not understand that. We have taken a continuous growth mode. So that's one. But even within that, see that kind of that continuous growth, rotation of capital, Now it is financialization of nature. All of this has come in. So once you have financialized nature, made it into a financial commodity to be traded, that
Right.
becomes even faster circulation. So
Hmm.
all this, I'm not going into details of those, the financial mechanism, because that's one of the major areas that we need to tackle, the global financial mechanisms.
Hmm.
But leaving that apart, the climate change part is basically driven by greenhouse gases. Okay,
Right.
any kind of growth will not do growth of greenhouse gas. Supposing, I'm not saying that is the ideal, but a hypothetical situation, supposing all our energy comes from non-fossil carbon fuels sources, not fuels, sources. Whether it is solar, wind, geothermal,
Correct. Yes.
ocean thermal, wave, whatever, tidal, whatever energy, geothermal. There are 10 or 15 different kinds of renewable energies. We can also go into other kinds of energies. I'm not going into that. So supposing most of our energy, if not all, comes from those. So our industrial machine, our energy consumption will not put in greenhouse gases. That will not create climate change. That will still be extractive. That will
Hmm.
still be extracting some resources from nature. Okay. You
Right.
cannot live without extracting resource from nature. The fundamental question of how much and how do I limit myself, that means as a society, that still remains. But that will not create a climate change problem because the
Sure.
greenhouse
Got it.
gases will come down. So
Right.
this question needs to be understood in two different parts. One
Right.
is the direct, immediate, imminent threat of climate crisis. The second is the crisis of overly extractive, destructive and extractive economic system, which has gone beyond capitalism and now into other modes of destruction. So that's a much larger challenge.
Sir, also
Whereas,
sorry, go ahead.
no, carry on.
So it would be great to get your perspective on some of the, since energy transition to renewable sources is such a important topic. It would be good to get your views, sir, on the various sectors that you spoke about. For example, nuclear was an eye-opener for me. I always thought before today's call that nuclear is perhaps the most cleanest form of renewables that we can look at. Right, considering the fact that solar especially, the energy efficiency is not that great, right? So would be good to get your views, sir, on each of the various modes.
Right. Since the time is short, let me get into the see. One is nuclear was never clean because fundamentally, even if we don't have what I said, that nuclear has a huge embedded energy and embedded emission, and that's why it will take a very long time before it even start acting to be better than gas power plants. Okay, so beyond that, nuclear means when I'm talking about nuclear, I'm talking about nuclear fission, and today's fission power plants run on uranium-235. Okay, I'm not talking about possible nuclear fusion power plants because these are of entirely different nature, and their entire fuel chain is different. They don't have that radioactive signature for long-lasting radioactive signature, which the fission plants have. One major problem of nuclear fission plants, like all the world's 438 or 39 nuclear power plants that is running in the world today, all of them have a major problem of creating a nuclear fuel waste. After the usable amount of U-235 is used up, split, you have a huge amount of uranium-238, thorium, krypton, etc., a very toxic mixture, radioactive toxic mixture, where a large part is plutonium-239, whose half-life is for 24,100 years.
Wow.
And as a scientist, we think that it will be safe after 10 half-lives. That means 2,41,000 years. Who is going to store this huge amount of toxic, highly radioactive material? Plutonium-239 is a very, very radioactive material, and exposure to that is certain death. So who is going to take care of this for 241,000 years? Our entire civilization is less than 7,000 years. Okay. So these questions have not been solved. The nuclear, forget about the nuclear industry. Physics don't have an answer how you convert these heavily radioactive materials into non-radioactive material. All these fantasies about an accelerator-driven transmutation, all these, I studied nuclear physics in my university courses. So I understand all this falsehood that nuclear establishments try to spread. These are not feasible. So nuclear fission has some major problems that they cannot solve, that it has not been solved by physics itself. So engineering cannot solve it.
Correct.
And nuclear power plants continuously leak radiation as a part of their process. If you look at any nuclear power plant, the containment dome, you will see a pipe going up, and that pipe is used for venting. Because when the uranium-235 atom splits as a part of the fission process, it emits highly radioactive gases like iodine-131. So cesium-137 or 138. So these gases are highly radioactive. This has to be spread in the atmosphere, and they end up in the surrounding atmosphere and spread to populations if they are nearby. So how do you tackle that problem? Because that's fundamental to the physics of nuclear fission. So nuclear fission is actually very dirty process. It's and not only dirty process, we are burdening our how many generations? If you think even 5 half-lives is 1,10,000 years. So if you consider 30 years a generation, how many generations? 300 plus generations we are burdening with our dust, our waste.
Correct. Yes.
We have to tackle our waste. Who gave
Thank
us
you so much, sir. Yeah, thank you so much, sir. It's been very, very enlightening.
Thank you, sir. I think we can take one last question from Induji. She's asking how proactive is our educational system in addressing the climate literacy from a young age?
See, in our education system, one point of time we had some hope because, there was a Supreme Court, not judgment, observation, that environment education should be part of every level. So after that, the earlier government, they started introducing some lessons. But what has happened over the last few years is this obfuscation of what is environmentally correct. Today, we're acting less on scientific facts than on particular ideologies. And this obfuscation, this fooling of the public is in all sphere. Take one example. I'm not giving any names, but a very high-profile scheme launched by Government of India. Since I have been following the COPs, I've been going there. I think it was in Egypt, in Sharm el Sheikh, when we were there. This high-profile Government of India scheme, Lifestyle for Environment. So that was launched. So that says that 1 billion people of India, they are taking action for environment, etc., etc., etc. But look at what we are doing in India as a policy. Like you are saying, education. In education, have you ever seen a comparison between different modes of transport which says which mode of transport is more environmentally friendly? Simultaneously, as a policy, the Government of India and all state governments, they keep encouraging aviation, new airlines, new airport. Every state is demanding new airports, more flights. Everyone is demanding more. Even middle class people are flying very frequently, happily, not knowing, because there is no education given to them, no science behind all of this, that flying a certain distance, particularly short haul flights, like supposing I am in Delhi, if I fly from here to Bangalore, the amount of emission I do is around 200 kgs of carbon dioxide. If I go by even a good train's AC, my emission will be around 35 to 38 kgs. So 35 kgs versus 200 kgs. So which mode should I take? But happily, the government encourages flights. That's the modern thing. That's the in thing. That's the thing to be done. Who goes by train? Trains do regular accidents. So as a policy, we encourage flights. We encourage aviation companies. Everyone demands airports. People dream of flying. Where is the component in education which teaches us that this is environmentally completely unsustainable. It is actual destruction. And the amount of emission that we do by one such flight, Delhi, Bangalore and back, 400 kgs, in the entire year's, total years, everything together emission for a lower middle class person. So this is highly climate injustice is embodied into this. This is a very good example. But we don't know this because this is never taught to us. Our environmentalism is completely devoid of science. Our environmentalism is emotions, ideologies, false ideologies, and talks. So I don't think our education system is teaching environmentalism at all. Forget about the environmental courses, where the specific courses on environmental science, they are teaching some of this. But as part of the environmental course, science, environmental issues in every course, which was the Supreme Court's observation and desirable course, is very poor situation today. Unless we follow facts and science and data and figures, just talks and emotions will not help. They will take us to a wrong direction.
Thank you so much, sir. That was all the questions that we had. Another one we have from Abhinav Ji is asking, any thoughts on environmental activism? How can it lead the way?
See, environmental activism is a whole huge bunch of activities. You can resist some environmental destructive project. That's one activism, what we call environmental defenders, frontline defenders. And today you have to be careful because frontline defenders are often jailed or picked up by police. Another kind of environmental activism can be, okay, you quote unquote, you spread environmental awareness, which a lot of people have been doing. We have done this 30 years ago, and we have not seen too much impact of that because people become aware, but they don't change their actions. So those awareness do not get translated into action in 99% of the cases because people have not changed their actions of either travel or consumption or their lifestyles just because they are aware that this kind of lifestyle is environmentally unsustainable. That do not happen. The third kind of activism that you can do is look into environmental policies, environmental regulatory frameworks, and do analysis and try to advocate. That is advocacy. That requires a lot of skills and knowledge component. So that's another kind of environmental activism you can do. The fourth kind of environmental activism you can do is actually going to communities, helping them in one or two areas. Like, as I said, the heat index, high temperature, high humidity is actually affecting very large number of people of India today. Right now, this is first week of August, that you can see the heat and humidity, the temperature and humidity in most of India, central India, South India, all over. Except in the areas where there is heavy rains, it's very bad condition, even in Delhi. So you can go to communities, find out what are the problems they are facing on this, 1-2 areas of environmental issues, and try get knowledge about this and help them overcome this, surpass these problems, and establish resilience, a more resilient community. That can be a more, like if you work with any areas, like I said, inland fish workers. If you work with any inland fish worker community, see what kind of problems they are facing, which are connected with the environment and climate, and then help them overcome that. That will be another kind of environmental activism. On fifth kind of thing that you can do, and I will not go beyond that, is go somewhere, create an environment. Like a lot of people are doing this. They are buying a plot of land at somewhere far off. They are creating a forest. Some people are restoring a small stream. Some people are creating water harvesting structures in villages and creating greenery around them so that people can have better irrigation and the vegetative growth around that happens. And some of my younger friends are doing this in Rajasthan and other places, Rajasthan, Maharashtra. So that's another fifth kind of environmentalism that you can do. So it's up to you what you will be able to do, what suits you.
Thank you so much, sir. That was the last of our questions. I would like to thank you for being with us here today. It's always a pleasure learning from you, and we keep hoping that we'll keep collaborating with you in the future as well. Thank you so much, sir.
Thank you. Thank you, everyone.
With that, we'll now proceed to our chair, Bhargavi ma'am, for her remarks on today's program. And next, we'll be proceeding with the program participants' introduction part of the session, for which either the participants can raise hand and we can continue in the order, or we'll just call out the names and we can proceed likewise. Over to you, ma'am. The floor is all yours.
Thank you, Priyanka, and I cannot agree any less with what you just said, because it's such a pleasure listening to Soumya Dutta. Every time I listen to him, there is so much that I learn myself, and I think Soumya very beautifully demystified all the scientific aspects of climate change from the Indian subcontinent and the South Asia perspective. Not many of us even would, have the time and the bandwidth and to understand what the IPCC says or any other scientific report says. And Soumya very beautifully broke that into different components and explained the whole thing to us. And simple things like how the surface temperature around all the water bodies around India is increasing, and how that is adding to the storms, the very powerful storms that we experience. And even simple things that he mentioned about how the amount of rainfall has not decreased or increased. It's the number of days that we get with such high intensity. I think all are these aspects that he explains is very appealing to a common man and to most of us who may not come from a science background. So it helps understand and comprehend all these things very effectively. And also how he highlighted many factors from a Indian subcontinent point, like how the landmass, the increase in temperature over the Indian landmass is just about 0.71 degrees compared to what is happening in the global north. And everything else that he broke down and explained was, I think, extremely useful to all of us. And he moved on to the 4 different regions, and I think that was again very interesting because most of us live across these 4 regions, and we are seeing climate change impact our everyday life and the lives of others around us. So it definitely helped everyone comprehend, and I did see how Dr. Sigdel also commented on what is happening in the Nepal area, where the snow is melting, and the challenges that are being faced in the Himalayan region. And he very beautifully explained what is happening in the coastal region and its implications on the fish workers. This is only from a climate change perspective, minusing the factors that, all the other man-made challenges are just, compounding that problem. Then also what is happening to the Indian, central Indian region, where the forests are catching fires and they are thinning out, and how the different kinds of invasives are taking over. These were very interesting. And of course the urban areas. And then lastly, he focused on all the different sections of communities who are facing the brunt of all this, particularly the farmers, the fish workers, the street vendors, hawkers, and to add to that, the Paura Karmikas, or the solid waste workers in our cities, and those working in the gig economy. All of these people are the ones who are facing the impacts of climate change. And then he went on to something that is very important about electricity itself. Like, on one hand, we do know that the different ways in which electricity is being produced, particularly coal, while how that is adding to the climate change problem, in order to mitigate climate change and its impacts on human lives and livelihoods, we again need electricity. So how do you find a just way to find the different ways in which electricity can be produced and it can be made available to these sections of society, particularly given that the number of hot days are increasing and their work life is getting increasingly challenging. And then he also touched upon a very important aspect of transport and the various challenges. I love the way how he explained air travel, because given that city after city is competing with each other to build more airports and expand airports, I think that was very interesting. How a train journey can definitely burn just 30 kgs of carbon, as he said, from Delhi to Bangalore, while it could be like 200 kgs. I think that was a great example that Soumya Dutta gave. And on the whole, I think it was a very eye-opening and a very comprehensive talk to start off this course. With this, I'm sure all our participants will have a variety of thoughts, and it will help them pursue in what way they would want to kind of work on this, or take it up in their own work life, or if they are students or if they are researchers. It will help them think of the ways in which each of us can work on these nuances and help build resilience in and around wherever we are and help mitigate climate change. So with those thoughts, thank you so much, Soumya, and thanks, Priyanka, for giving me this opportunity. Thank you.
Thank you so much, ma'am. You beautifully encapsulated the program so far. And with that, we'll now proceed to the participants' introduction part of the program. We'll proceed with the ones who have accepted the request to join as a panelist. To others who are unable to, you might be getting a request on your screen to join as a panelist. Accept that, and you will be rejoining this week's session as a panelist. That will allow you to open your videos and audios as well. With that, we'll start with Deepa ji. Deepa ji, would you like to go ahead and introduce yourself?
Hi, can you hear me?
Yes, we can hear you.
Hi, I'm Deepa Valavalkar. I work as a monitoring and evaluation lead at a domestic philanthropic organization in India. We are recently moving from doing working across multiple sectors to now working in climate resilience in urban areas. So the last 2 hours have been great. It's been like a crash course in understanding all things about how climate and different things interlink with it. I'm very much interested to absorb all the things that are going to come forward, and I hope it also helps contribute to making a more robust theory of change for our organization, to see the interlinkages between climate, health, livelihoods. That way. Thank you.
Thank you, Deepa ji. Next, we can have Astha ji. Astha ji, would you like to go ahead? We're not able to hear you. Astha ji, we're not able to hear you.
Hello. Hello.
In the meanwhile, Abhinav ji, you can go ahead.
Yeah, sure. Can you hear me?
Yes, we can hear you.
Yeah. So hi, I'm Abhinav. I'm a master's student of socio-ecological economics in Vienna, Austria, and I finished my bachelor's in economics in India, and I'm very excited with the summer school, particularly understanding the linkages between society and climate change, particularly in the Indian context. So and have always admired the work of Bhargavi ji and Soumya ji. Thanks.
Thank you, Abhinavji. Jay Pawarji, would you like to go ahead?
Yeah. Good evening, everyone. I am Dr. Sai Pawar. I am the director at Deepak Foundation. We are a civil society organization headquartered in Vadodara, Gujarat, but we work in 5 other states. And one of our major sectors of work is natural resource management. We work a lot with the communities, and we also work with ecological restoration. Public health and education are also, our other domains. So I really look forward to attending this course and listen to all the eminent speakers, and that should give us wonderful insights on how we could take our work further as a civil society organization. Thank you.
Thank you so much. Manisha ji, would you like to go ahead? Wait, Satviki ji, would you like to go ahead?
Sure. Am I audible?
Yes.
Hi, my name is Satviki Adla, and I'm a student studying conservation science at IMPRI. I really enjoyed the course structure of and the course content that you had shared. Plus, all of the panelists who are coming in have come from varied experience and backgrounds, and that was really interesting for me. Since I intend to do a thesis around climate change, I thought this course would give me an edge. Yeah, to eke out my uh, thesis report. Yeah. Looking forward to the sessions.
Thank you, Satviki ji. So, Dakshina Ghosh ji, would you like to go ahead?
Yes. Hi. Thank you so much, Priyanka. Of course, it was a great session, an excellent way to begin the course. To introduce myself, I work as a consultant and a practice lead for a large technology company, and have been involved with advising businesses on sustainability and how technology can drive sustainable business processes. My experience so far has been that, because of the emerging regulatory focus, sustainability is looked at largely from the view of a regulatory and compliance lens. In terms of like bringing about real changes to business process and ensuring circularity or ensuring this energy transition, etc., there is still some way to go, right? And it is for me as an advisor to companies, and as an aspiring investor, I want to also build my my capabilities around impact investing and how to really evaluate enterprises that work in the area of sustainability and climate tech. So it's very interesting to hear the perspectives of experts who come from so many diverse fields and bring in their knowledge, because then it also helps me to strengthen the advisory services that I am able to provide for the customers of the company that I work in right now, and then in future, when I work more closely with companies and startups who are in this area of sustainability and climate tech. Great session. Thank you so much. Priyanka, I just had a question. You mentioned in the beginning of the class that, the reading material has been shared. Where is the reading material shared? I only have an email from Zoom saying that the registration has been accepted. So if that material can be circulated, that will help.
Yes, it will be circulated today as well, along with the video day one.
Okay.
Yes, so the video will be shared, and you'll find the course outline and reading resources document attached to your respective emails.
Okay.
If you just scroll down that document, you'll find the table which has all the reading resource material.
Okay, thank you so much.
Yes. All right, thank you. And next, Atika Hassan ji, would you like to go ahead?
Yes. Hello, everyone. I'm Atika Hassan, and I'm a PhD scholar from Jamia Millia Islamia. I'm at the Center for Peace and Conflict Resolution, And my thesis focuses on the climate crisis issue in South Asia, and with a particular focus on climate migration and climate-induced displacement, which was related to the question that I had asked, sir. So for me, today's session was a very good introduction into the area of climate crisis that is facing in the region. And I'm really looking forward to the rest of the scheduled session. I think for my thesis and just a general overview also of the climate change happening within the region, it will be very useful and enlightening for me. So that's what I'm hoping to learn from this session. It was lovely meeting you all, and thanks, Priyanka, for hosting it. Thank you.
Thank you so much, Atika ji. Induji, would you like to go ahead?
Okay, I'm Indu. I'm from Kerala. I'm working for the Kerala Forest Department, mainly dealing with the land related cases. And my important domain is to, of course, dealing with the forest land cases, convincing courts on the importance of forest protection and all. And I occasionally involved in the preparation of management plans, working plans, etc. for the forest department. Also, I work with the communities, especially the forest dependent communities. Actually, like I had much, I was not familiar with the domain of this climate change. Recently, it happened to me to participate in a climate change related session, and that motivated me to learn more about the nuisance of the climate change, especially in our, like in the way we live, how it will impact on our future, or especially the survival of the humankind as well as the environment. So that is what motivated me to join in the session, and it was fun. It was a fantastic opening. The first session was extremely well done. Thank you very much. Thank you all.
Thank you, Induji. Yogendra ji, would you like to go ahead now?
Good evening, everyone. My name is Yogendra, and I'm working as associate faculty in Institute of Livelihood Research and Training. And from last 5 years, I have been working in waste management sector, and we are providing support to different ULBs in extreme solid waste management. So I just wanted to understand the linkage between waste management and environment, so that we can intervene in our geographical area and convince the stakeholder to go beyond waste management, how we can bring waste into self-economy. So that's why I am. Thank you.
Thank you, Yogendra ji. Next, can we have Kamtinlal Dimgel ji? If you're here, you can go ahead.
Can you hear me, ma'am?
Yes, we can hear you.
My name is Kamtinlal Dimyel. I'm from Manipur. I'm a PhD scholar in Manipur University, and I'm joining this program because I want to know about the climate change, and even my PhD thesis is also related to a little bit about climate change. Thank you.
Thank you so much. Astha ji has introduced herself in the chat, so I'll just read that out. She's done her master's in politics and international affairs from JMU, and she says that I have taken up this course to diversify my knowledge base. Thank you, Astha ji. Neelam ji, would you like to go ahead now? Okay. If not, then Rashmi ji, would you like to go ahead? Okay. Then last, Ritesh ji, would you like to go ahead?
Hello, can you hear me?
Yes, we can hear you. Please go ahead.
Yeah, my name is Ritesh. I work with a petrochemical industry firm, R&D, working on the technology management side, looking into chemical process industry related problems and technologies. So recently, there are a lot of initiatives in our organization related to sustainability. So that is one reason I wanted to understand topics like climate change, sustainability in a broader sense. Otherwise, I don't have any direct hands-on experience or background in environment or climate. So this is more of a academic interest. I just wanted to get a broader perspective of the subject like sustainability and climate change. So that's the motivation of joining this course.
Thank you so much, Ritesh ji. With that, we conclude the participants' introduction section. I would now like to ask Bhargavi ma'am for
Hello.
some final remarks on the session.
Hello, ma'am.
And yeah, yes, Manisha ji, yes, please go ahead.
Hello. Actually, I also wanted to give an introduction. Yeah,
Sure.
so yeah, I'm an engineering student, a bachelor's of engineering. This climate change factor, like this climate change is drastically seen everywhere. Like we are experiencing in day-to-day life. So I just want to explore this field and know elderly perspectives on these climate change topics. So, and yeah, I have a big vision to work on this field. So that's why I hope I get a lot of insights from this course. Thank you so much.
Thank you, Manisha ji. Do any of the participants who are left would like to give their introduction now, or they can also put their introductions in the chat box? Okay. Okay, then we'll go ahead. We'll go to Bhargavi ma'am now. Ma'am, some final remarks on the session now that we know the participants a little better.
Yeah, thank you, Priyanka, and thank you everyone for introducing yourself.
Ma'am, we can't hear you.
Can you hear me now?
No, still not audible.
Oh, I'm so sorry. Can you hear me now?
Yes.
Okay. Yeah, so thanks everyone for introducing yourselves. I think that was a great introduction because it helped understand your background, what you're currently doing. And it's a great mix of students, participants for this course coming from such diverse walks of life. And I think that is the beauty of these kind of programs, where you not only learn from the people who are going to be speakers, but there's so much to learn from each other as well. And this peer-to-peer learning will definitely help understand a lot more about the nuances of climate change and the points at which actions have to be taken and reimagined, if I can say. And another interesting thing was there is a good mix of researchers, students, and also working professionals who are already in the field and who have some exposure and trying a variety of solutions. So I really look forward to the next few weeks where we can all learn together and learn from each other as well. Thank you so much.
Thank you so much, ma'am. With your permission, should we go ahead with the formal vote of thanks?
Sure.
All right. So as we come to the end of day one of understanding the nuances of climate change in the Indian subcontinent, Cohort 2.0, an online international monsoon school program, a 2-month immersive online introductory certificate training course organized by IMPRI, I, Priyanka Negi, researcher at IMPRI, Impact and Policy Research Institute, would like to propose the formal vote of thanks on behalf of IMPRI Center for Environment, Climate Change and Sustainable Development, New Delhi. We are grateful to our expert for the day one session, Mr. Soumya Dutta ji, for taking out valuable time and thought-provoking insights on the topics. We thank our chair, Ms. Bhargavi S. Rao ji, for convening the session. We thank all of our participants who have raised pertinent questions and actively participated in today's deliberation. Readings for the session have been shared in your email, and a video of the session will also be shared with you for learning. We look forward to welcoming you for our second day of the certification course on 10th of August at 4 p.m. We're grateful if you're watching this later on YouTube or listening to us on our various podcasts or reading our publications. We hope you continue to join us in the future for our IMPRI Web Policy Talk and Web Policy Learning. Wishing you a very good evening and thank you, everyone.
Thank you, everyone. Have a nice weekend.
Good
Thank
night,
you,
ma'am.
Priyanka. Thank you.
Thank you, ma'am. Thank you so much.